Welcome back everybody to another Swift programming tutorial. In this tutorial we're going to go over the different basic forms of Swift closures. Before we get started, a quick definition. Closures are self-contained blocks of functionality that can be passed around and used in your code. Closures in Swift are similar to blocks in C and Objective-C, and to lambdas in other programming languages. Sometimes referred to as anonymous functions, closures are similar to functions without names. Closures can be especially useful when passed as an argument to another function. Closures can take many forms, and there are also some special types of closures, such as trailing closures, escaping closures, and auto closures. In this tutorial, we will go over a specific example of a trailing closure, and then we will touch on the escaping closures and auto closures at the end. Okay, so the basic form of a closure looks like this. The closure defines the parameters or arguments it will work with. Then you return and determine what you want to do with those parameters or arguments. So in our examples, we're going to go over a comparison of a normal function and a closure that does the same thing. And as we go over our examples, comparing our function to our closures, notice the similarities. Both the closure and the function use parameters or take arguments, and then return those arguments changed somehow. Okay, before we go over the different forms that closures can take here, let's go over a normal function which will help us better understand our closure forms. So here we have an array with the values 5, 2, and 10. We want to create a function that looks at each of these values and adds them up together, giving us a final total or sum. So to create that function, we use the reserved word func. We gave our function the name addFunc. This function will take an argument, or we have defined the parameter of in type double as an array. Then it will return the sum or total of type double. We've gone ahead and created a variable. We started it out as 0. This variable will eventually accumulate all of the values in this array to give us our total sum. That's why we started out at 0. Then we use a for in loop, which will help us loop over or through our array values. We use our sum variable that we created here, that we started at 0. We use our plus equals operator, which will help us create our running total of sorts. Okay? So what will happen is, using the I from our for loop, this I will iterate through the values, and each time it encounters a new value, it will add it to sum. So basically, I will look at 5, and it will add that to the sum. Then I will look at 2, and it will add that to the sum. And then, finally, I will look at 10 and add that to the sum, which will give us 5 plus 2 plus 10, returning that sum. Now here, we've gone ahead and assigned our function to this variable, and we've passed in our numbers array. Let's go ahead and use a print to display our sum. Let's run it. And you can see 5 plus 2 plus 10 gives us 17. Okay, so using the reduce function and our closures, we can do the same thing that we've done here with our add function. Now we've gone ahead and we've assigned all of these different forms that basically do the same thing to our different variables. Some reduce 1, some reduce 2, and so on. Now the reason we wanted to show you all of these different forms is because you may see these different forms from time to time, and you'll also have to decide when you use the closures which form you prefer to use. Now, before we go over the closure syntax, let's go over the reduce function. So over here in our help screen, we can see that the reduce function has two parameters. So first, the initial result would be 0. just as in our normal function, we started our sum off with 0. So let's go ahead and read that. The initial result is the value to use as the initial accumulating value. Initial result is passed to the next partial result the first time the closure is executed. The next partial result is your closure, and that is a closure that combines an accumulating value and an element of the sequence into a new accumulating value to be used in the next call of the next partial result, closure, or returned to the caller. So, the specific steps of using the reduce function: first, the next partial result closure is called with the initial result 0. And if you're doing other operations such as subtraction, multiplication, division, that would be different. But since in this case we're using addition, we're going to start it out at 0. The second step, the closure is called again repeatedly with the previous call's return value and each element of the sequence. And the third step, when the sequence is exhausted, the last value returned from the closure is returned to the caller, giving us our final result, in this case the sum. Okay, so having read those steps, this will help us to understand what this closure is doing, and you'll also notice that this reduce with our closure will function very similar to this function here. So the first thing you want to do to use your reduce is reference your array that we created here. Then we use a dot, reduce. We start our accumulating value out at 0, just as we did here. Now this is the first form of the closure. You'll notice we have our curly brackets here and here. Then for the parameters, or the arguments that the closure will work with, we have num1 and num2, both of type double. Then we use our return symbol, which is a dash and a greater than symbol, which looks like an arrow. It will return a type double. We use our special reserved or keyword in, and we use return to determine what we want to do with these parameters, which is we want to add them together. Okay, so this closure syntax will help us accumulate and add each value to a final output, giving us the total sum of our numbers array. Okay? Now notice that this is quite long. You can do the same thing with closure syntax with shorter syntax. And this is kind of where your personal preference comes in. So in this case, we've done basically the same thing as we have done here. We use numbers.reduce. We start out our accumulating value at 0. However, instead of creating our parameters like this, all we have to do is create simple parameters like this, because the types double can be inferred. Now the return type can also be inferred, so we do not have to put that in. So in this case, we use the in, and then we return what we want to do with x and y, which is basically, we just want to add all of the values together in the array. So you'll notice we went from a very long form to a shorter form, and basically the change from this long form to this shorter form is that the types can be inferred. So we can leave out the double types. We can shorten this form even further by getting rid of the return keyword. Okay, so in this case, we state our parameters, we use in, and then we say what we want to do with those parameters. Again, just adding them all together. Now, there's an even shorter form here using a special shorthand syntax. So we have some notes on that. Swift automatically provides shorthand argument names to inline closures, which can be used to refer to the values of the closure's arguments by the names $0, $1, and so on. So you can kind of think of this $0 as being equivalent to our num1, num2, or our x and y. And again, basically using that same accumulating effect to sum all of the numbers together, we can put $0 plus $1. Now, finally, you'll notice in all of these earlier examples, we passed this closure in as the second argument. You can also do something similar but slightly different, and instead of putting those inside the function round brackets, you can take your closure here and put your closure on the outside. Now you have to be just a little bit careful with this type of closure because this may not always work depending on the function that you use it with. This type of closure is called a trailing closure. Okay, so we have some notes on that. A trailing closure is written after the function calls parentheses, even though it is still an argument to the function. Trailing closures can be useful if the final argument is really long and cannot be put inside the function round brackets on one line, or you can use them just for convenience. Now, finally, let's go ahead and use a print to display the results of all of these different examples. And what you'll see is the outcome will be the same. Let's go ahead and run it. Okay, 5 plus 2 plus 10 is 17. We put in our examples 1 through 5 with the different forms of the closures, and you can see we get 17 for all 5 examples. Let's go ahead and move on to our last 2 examples. As we mentioned earlier, closures can be especially useful when used with other functions. So for example, let's say that we wanted to use our same numbers array here, and we wanted to use the map function, and we wanted to take each element in that array and multiply it by 2. One way we can do that is to use numbers.map and then pass in a closure. So we're going to use syntax similar to our third example here, and we're going to say x, which represents each element in that array. Then we use in, and then we put in what we want to do with x, which is to multiply each element x by 2. Now notice in this case, we put the closure inside the map round brackets. And in this case, we use the trailing closure syntax. So let's go ahead and use a print to display our results. And you'll see we get the same results for both versions using this version and this version. So we get 10, 4, 20, 10, 4, 20, which is each element here multiplied by 2. And for our final example, let's go over how you could use a closure with the filter function. So in this case, what we want to do is take each of the numbers in this array and then only return the numbers if they are greater than 2. Okay, so we use numbers.filter. We create our parameter. We use in. Then we decide what we want to do with that parameter. Again, x representing each element in the array, and we only want to return the element if it is greater than 2. So in our array, the elements greater than 2 are 5 and 10, and that's what we get. We're good to go. That's all we have for this Swift programming tutorial on the different forms of closures. However, before we complete our tutorial, let's just quickly go over 2 other special types of closures. One is called escaping closures, and that is a closure that is said to escape a function when the closure is passed as an argument to the function, but is called after the function returns. An auto closure lets you delay evaluation because the code inside isn't run until you call the closure. Now we will probably go over these types of closures in a separate tutorial. We will be doing many more Swift tutorials in the near future. Join us for those, and we'll see you next time.